talk about ellipse. We want to write equations of ellipse. We want to find the foci. I always pronounce it foci. I've never really looked it up to see if it's proper, although I've heard people on occasion, I should say, pronounce it foci. But what it means is plural for focus. Okay? And yesterday, 2 days ago, we had the focus of a parabola. Okay, the point in which the parabola wrapped around was always equal distance from the graph to the focus. The focus as it is the graph to the directrix. Okay. In an ellipse, we have two focus points, so they're called foci. Okay. So we're going to learn how to find the foci and graph the equation of the ellipse. Right. That's what we're going to work on today. We have some terminology, we have a definition. We want to write this down. The next page we have a couple pictures, and there's a lot involved there, so I'll pause, let you copy that down. So anyway, the distance from the P represents some point on the graph, and PF1 means the distance from P to the first focus point, and PF2 means the distance from that point on the graph P to the second focus point. That distance always has to add up to K. And so as I showed you a string, a couple tacks, you can draw an ellipse. All right? And an ellipse looks like an oval or egg shape, or whatever you want to think of it as. All right? Next page, a lot of information here. I'm going to pause this so that you can copy it down, and then we'll go through it to make sure you understand what the arrows are pointing at and what things mean. I'm not going to make it disappear. It's still going to be there. It's just I'm going to start talking. Okay, just to make sure you can understand what the diagrams are trying to say, the major axis is color-coded. It connects the vertices. So the major axis is that segment that connects the two vertices together. The minor axis, green here, is the segment that connects the two co-vertices together. It's important to understand that this point of the vertice is the point A0, and this point here is the point opposite of A0. This is only true if the center of the ellipse is at the origin. If the ellipse is centered at the origin, then this would be A0 and this would be negative A, or opposite of A0. The co-vertices then would be 0, opposite of B down here, and 0, B up here. Those are the co-vertices. When we go over to this other model, the vertices are still A, but since it's on the y-axis, it's 0A instead of A0, opposite of A down here. And up here would be 0A, and then this one would be B0, and this one over here would be the opposite of B and 0. Notice down at the bottom here, A has to be a number bigger than B, and they both have to be bigger than 0. Okay? A has to be bigger than B, and they both have to be bigger than 0. So when A, the bigger number, is underneath the X, then the ellipse lays in a horizontal manner. The major axis is horizontal. When A, the bigger number, is under the Y, then it lays in a vertical manner where the major axis is vertical. Okay? So that helps you understand when you're looking at an equation where the numbers go. And you notice that in both models, everything is on the left and it's always equal to 1. And so if you have an equation that's equal to some other number, then you have to move that out of there. And in this case, we're going to be dividing everything by that number to make a 1. If I subtracted that number, say I had 9 over there, and I subtracted 9, I'd get 0, right? So to get rid of it and make it a 1, I have to divide by whatever that number is. Okay? Any questions on that? All right. The foci we've already talked about. Was that self-explanatory, the arrows there? So the co-vertices are the ones that connect the minor axis together, and the major axis and the endpoints of the major axis are the vertices. Sorry. Okay? All right. We can come back to this if you're not exactly done with it, or you want to come back and color code things later. We can always put this up when we're done, but I'm going to move along now. We have the value of C. C is the distance from the center to the, well, that's why that looks. I drew that the first time, I thought, man, my value of C on the left looks a lot different from my value of C on the right. Would you agree with that, Garrett? Yes. Yeah? So it was because my ellipse wasn't actually centered at the origin. So this looks a little better. So again, this model, just by looking at this, I know that this model is going to be x squared plus y squared equal to 1. What goes under the x this time? A? It's either A or B, A squared or B squared, right? So which one would it be? Okay, is this horizontal or vertical? Yeah. Yeah, since the x-axis is longer, the horizontal axis, the major axis is horizontal, the x value is bigger, the A would go under the x, or the A squared. And so the B squared would go here. So this is the model we would be looking at. Okay? And C is the distance from the center to the focus. And so on the other side, C is still that distance from the center to the focus. They're equal. Okay? So if that distance was 3, let's just pretend for a moment that C is equal to 3, then what would the coordinates of that focus 2 point be? 3, 0, right? What would the coordinates of the F1 focus point be? -3, 0. That's correct. If you didn't hear, if it didn't pick up the recording, this one you said was 3, 0. That's correct. And this one would be -3, 0. Okay? And so if I knew that B was, this won't be as, shucks. Well, I just made something up. If I just make it up and say B is 2, okay, then this point here would be this this co-vertice point. What would the coordinates of the co-vertice be? 0, 2, and 0, -2. And so that means that the distance from the center to the co-vertex is 2, so the number here would be what? 4. So it would be y squared over 4. And now I need to find the A value. And so we need to understand this, which you've seen many times. A squared plus B squared equals C squared. That's the Pythagorean theorem. It's appropriate in this right triangle. And this is where it's a little tricky. I'm going to highlight this, or I'm going to draw this again with a red. That distance right there we called A. If I took that distance, and I can't do it, but if I took that distance, moved it over here, and swung it down, the distance from the center to the vertex is also A. Okay? So that hypotenuse of that little triangle we created, from the focus to the center up to the covertice, that hypotenuse is the A value. Oh, and then as I look at this, I realized I wrote this wrong. Sorry about that. The hypotenuse is A, not C. Okay? And so if I remodel that, I would get, hold on, I don't want to write it differently than they did. You can go back and look at it and be confused. Yeah, okay, good. We're on the same page. And so, excuse me, if I remodeled this, I would get c squared is equal to a squared minus b squared. And if I just subtracted b squared from both sides, I get c squared equals a squared minus b squared. And so, really, this is the model we want to look at. I apologize, I wrote that down wrong. I'm just in that.
But since we're finding A, wouldn't we want to put A by itself?
Yes. But, yeah, I'm not denying which method I want. I just want you to understand that this is the model we're going to look at in the relationship between C and the other two. Okay? But this red line represents this hypotenuse, which is the A value. Okay? And so, in Pythagorean theorem form, it's going to look like this. But more than likely, you're going to be using it the other way around. In other words, you're going to have the A value right away. You're going to have the B value right away. Actually, the A squared and the B squared, and you're going to need to find the C.
Okay.
Right? For most of what you're going to do, you're going to need this model right here. Okay? And we're used to A squared plus B squared equaling C squared, which isn't true in this scenario. I mean, you know what I'm getting at?
Yeah.
Okay, I'll stop then. So, again, this red line represents the distance from the focus to the co-vertex, okay? And it's also equal to the distance from the center to the vertex, all right? So, if we do this here, we can find, and you're right, the top model will help me find A better in my scenario here.
What would it be root
A squared is equal to C, which was what?
C was
So that's 3 squared plus B, which is 2 squared. So we get 9 plus 4. So A squared is equal to 13. Now, I agree A is equal to the square root of 13. But in the model, do we want A?
no, we want A squared.
No, we want A squared. A squared is the number that goes there, right?
Yeah.
So we want this number. And so x squared over 13 plus y squared over 4 gives us the equation of this ellipse. Okay? Yeah, it can be. It gets better though if you get after the homework, ask questions, and you practice a couple times, it does get better. Okay? It's not as bad as it looks when I throw the whole mess at you in a 15-minute period. Okay? So we'll go from there. Well, I'm going to look at the homework, and we'll pick a problem similar to what you're going to have to do, and we'll do one more example. Okay? Let me pause while you. Okay, modify the assignment slightly. 4 to 44 by 4s now. So that's only 11. And then 56 and 60, I want you to do those. Let me pick an example. I think this is like number 34. Okay. Is it in the form we need it to be in? No, because how do we know for sure it's not?
64 over there. It doesn't equal 1.
It's not equal to 1, is it? And we need it to be. So how do I get the 64 out of there? I divide every term by 64. And you don't want to make this all 1 and divide it by 64. That's going to be confusing, even to guys like Garrett that don't have to always watch. Okay? So that'll be confusing, so you don't want to do that. All right? Divide each one individually. How many times is 16 going to 64? 4. So that reduces to x squared over 4. How many times is 4 going to 64? 16 times, so that reduces to y squared over 16. And what is 64 divided 64?
7.
1. Okay? So is this model going to have a major axis vertically or horizontally? I'm hearing a lot of
It's vertically because
Vertical.
is under there, and A has to be.
Sabrina?
How'd you get the 4? Because 16 over 64 is 10625. You reduce the fraction.
No, I think if I divide 16 and 64 both by 16, I get 1 over 4.
16 over 64.
Oh, so you're still divided by not actually.
Which is 1 over 4, Sabrina.
Oh, okay. I got it.
AJ's like,
AJ, you got it? You got it,
Okay? I don't think that decimal you read off is the right
I was
decimal.
doing 16 divided by 64.
But you should have gotten 0.25. Not something else.
Your calculator might be in a different form.
Oh,
Okay.
I did.
All right, it's okay. We're caught up now, right?
Yeah.
All right, now let's go back to the question. The question was, is this major axis going to be horizontal or vertical?
horizontal.
And we're saying horizontal, why? AJ, you're saying vertically because?
A has to be larger than B, and A is under Y in
Yes,
vertical.
that's what I was meaning.
Okay, if we go back to this, right here we said that A has to be bigger than B, right? And so in this case, the bigger number is under the y squared, so it's going to be, it's right here, it's like this one, under the y squared, so it's going to be vertical. And so if I graph this, which I'm not going to do yet, okay, in 32 they want me to find the vertices and co-vertices. Did they also say the foci?
Yeah, I think it was.
Okay. Find the foci of each equation of the ellipse. All right. So we're going to do the whole thing to this. We're going to find the vertex, the vertices, the co-vertices, the foci, and we're going to graph it. And that'll kind of cover all the different types of questions you'll be asked to do. Max?
How do we know the center's going to be at 0?
Because it doesn't look like this. What's happening is I have x plus, or x actually minus, sorry. We'll learn this in lesson 10.6. I'm subtracting a 0 from the x and y, so I just get x squared and y squared.
Will we have a problem that gives us like x squared?
Not in today's.
Okay.
In lesson 10.6, we'll learn how to move it around on the coordinate plane so it's not always at the origin. Those numbers won't be 0 anymore. Okay? Good question, just not necessary for today. But in 10.6, that's exactly what we're going to do. Okay? So in this case, it is centered at the origin. something like this. What is A? Let's do this. What's A squared? 16. And so what's A? 4. And we said that A squared is under the which variable? The y, so the major axis is going to be up and down 4 units from the center. So if I go up 4, I go down 4, I get this. Those are my vertices. Okay, what's B squared? 4. So what's B going to be? 2. So those are where my co-vertices are. They'll be on the x-axis. So my vertices were, 0, 4, 0, negative 4, 2, 0, negative 2, 0. Okay? I could graph this now. Yeah, cheat.
That's not really driving, that's like drawing.
Good enough.
Close.
Cheaters never win.
So look something like that. Still better than we'll do freehand. You okay? So anyway, my ellipse, not my parabola, my ellipse looks like this. Now the question also asks, where's my foci at? And so that's where I go back to c squared is equal to a squared minus b squared. And so c squared is equal to 16 minus 4, which is 12. C then is the square root of 12. How does the square root of 12 reduce? I should say simplify.
Not 2 plus or minus the square root of 4. I mean, 2 plus or minus the square root of 4.
Well, you're close. You're really close. You're confusing it just slightly.
Plus or minus 2 square root.
If I forget about the plus or minus for a minute, how does the square root of 12 reduce? 3 times 4, the square root of 3 is square root of 3, the square root of 4 is 2. So the square root of 12 reduces to 2 square root of 3. Now the plus and minus doesn't go between those numbers, it goes in front of those numbers, right? So this reduces to plus or minus 2, gosh darn it. You saw my finger, I wrote better than that. 2 square root of 3, okay? So that is how far it is from the center to the focus. So square root of 12, that's like between 3 and 4, isn't it? Probably pretty close to halfway between. Okay, just a second. So 1, 2, 3, 4. So it's going to be right in here somewhere. These are where my 2 foci go. Okay? And the coordinates of this are going to be 0, 2 square root of 3, and 0, negative 2 square root of 3. Those are my foci. Okay?